All right, so I'm Todd Frederick. I am local here in Denver, and I work for eCollege. I'm an architect, and my responsibility is primarily RESTful APIs and API best practices. I've been a Java guy since 1998, so I guess that kind of ages me. I did C and C++ before that, started in the aerospace industry, and been happy to move to the more internet, high-scale world. I've done over 10 years of services. As you know, REST hasn't been around that long, really. So I started with JMS and XML and SOAP. My favorite was SOAP over JMS. I say favorite with air quotes, you know. So I go back to the Axis and Axis 2 days in Java. I've been doing REST, you know, more strict REST for over 4 years now. So I've had a good time with that. How many of you have done REST services? Okay, no, not really? All right. Are you familiar with the REST concepts or the constraints? Okay. All right. So basically what we're going to do today is I'm going to briefly cover the 6 constraints of a RESTful architecture, and then we'll kick off our project, which we're going to build a RESTful service suite for blogging system. And we're going to do some fun things and incorporate pagination and links and filtering and sorting and those kind of things. And kind of give RESTExpress a tire kick. All right? So REST is an acronym for representational state transfer. And for those of you that are familiar with the constraints, I apologize. I am going to breeze through them pretty quick, but I think it's important that we're all on the same page, because some people say, "Yeah, I know what REST is," and it isn't necessarily the same definition of what somebody else thinks REST is. So I want to just cover it, so maybe we'll get at least closer to be on the same page, if that makes sense. Roy Fielding wrote his doctoral dissertation on representational state transfer, and I believe later in the slides I have a link to that dissertation, so those of you that copied the slides will have that. The underlying premise of that is that it embraces the web as it was meant to be used. So we have the methods get, put, post, delete, options, header, head, those kinds of things. It's resource-based, uses representations to communicate back and forth, and it is constrained by these 6 constraints, or it's defined by these 6 constraints. Uniform interface, stateless, client-server, cacheable, layered system, and code on demand. I'll just go through those, each of those a little bit here, but I kind of got a kick out of this comic. Did anybody read Geek for Dummies? When you want to see the invoice with the ID 42, just type this whole big long phrase with ending in ID equals 42 into the address bar. Isn't that uber cool? And he walks away, and it's Jason. What a strange person. So I realize, I am aware that not everybody shares my enthusiasm about RESTful APIs, but anyway, I'm glad you're all here so that we can spend time together. All right, uniform interface is the first constraint of the RESTful architecture style. To me, you know, it's like, to me this is the one that's the most complex, and it's the most one that people differ about probably the most, because it also has some sub bullets that go along with it. But overall, it's how you identify resources in your RESTful system, and they're manipulated by representation. So for us, since we're using HTTP, we'll be using HTTP for our REST services. The REST architecture doesn't dictate HTTP, it just means use the protocol that exists, and we've chosen HTTP. So for us, the identification of resources is that URL. And you noticed in the previous slide, it's different from upside down. The previous slide where they have this big long URL and then a question mark ID equals 42. For me, that's not RESTful, because the ID equals 42 isn't really formally part of the URL. Still makes a good comic, but not a very good RESTful interface in my opinion. Okay, so the resources are identified by the URL for us. Resource manipulation via representations. Good, I think we're all good with that. Usually our representations are in JSON or XML. Hypermedia as the engine of application state. Okay, this is where people start to go off in the weeds and they start to deviate. It's like, well, what does that mean? Good question. Roy has spent a fair amount of time talking about it since his dissertation. But in essence, ideally what you want to be able to do is hit a root URL and have enough metadata come back with that representation to be able to navigate the rest of the API. So that's pretty mature REST API, by the way. So a lot of people don't go all the way. Anybody familiar with the Richardson maturity model? No, I can't remember. Leonard Richardson. He wrote the original O'Reilly book, Restful Web Services. And he kind of described 4 layers of maturity in a RESTful architecture. And I met him here a couple of months ago, and he's like, well, darn, I should have gone on because there aren't just 4. But anyway, his 4th level is where you're leveraging hypermedia and those links in the service bodies that come back. So self-descriptive messages. Let us go on. So identification of resources. You'll notice that I used kind of the example in the comic here. So customer 42, the 42 is the customer ID. It's part of the URL. So that's what we'd like to adhere to because that's a formal piece of that URL. Another key point is you can have multiple URIs or URLs referring to the same resource, and I'll show you those. It's kind of an example of that later. I kind of call those aliases because they might have the same thing. The URL is hierarchical; it gives a little context, and this really, to me, when I talk to people about RESTful best practices, resource naming is like key to understandability and usability of your API. And their resources are things, so they're named as nouns. Even this, people get confused because it's like, well, a lot of times I'm requesting something to happen on a server, but it's still you can still make it a noun. So like this, processes. Well, can be a verb. So processes, annual tax increase for 2012. It's it's just the way it's phrased is still a noun. All right, resource manipulation by representations. So the state that's going from the client to a server, a REST API, is just part of it can be just piece of the state, but we're going to use JSON and or XML in this. One of the tools that I have doesn't work very well for XML, but browser works great. So anyway, in essence, you do an HTTP GET on customers 42 for this host, and you accept application JSON. You get a JSON body response back. That one's pretty straightforward. Hypermedia, like I said, this is a more advanced model. So for us, we recommend at a minimum maturity, maybe. We recommend that at least when you do a post to do a create, that the server respond with a location header. So we don't necessarily require a response body, but it needs a location header with a link in it. And here's kind of it's really hard to read. I tried to format it and it doesn't work very well in PowerPoint here, but so this doesn't even look right. Evidently I got heavy-handed with my formatting. So this should be an href with should have a rel style relation. So ignore this part. The links here, we're using Atom style links. If you're familiar with those, it's basically just has a relation type, an href, which is the link, and then you can have a title or a type. Those two are optional. So here we have on an order 33. We have, this is how we got it. So this is a relationship to itself. And then we have some line items, evidently, that are related. And this is how we would retrieve the line items for this order. So that's how, if we had what if we said, without the 33, what would we expect to get?
All the orders for it.
Right. So we might get a list of these guys, and then we would have a link in there that would probably be this link, say, related customers. Everybody with me so far? Yeah? Okay. Like I said, I want to breeze through this just so we're on the same page, but I don't want to leave anybody behind either. All right, so self-descriptive messages. So far, we have two sides of the equation, the client and the server. You've got the HTTP GET, or the operation that we're going to do, and by using the standard HTTP methods. All right, so, and I've had some people ask me, it's like, well, HTTP allows us to create custom methods. Can we do that for a RESTful API? No, because you're not leveraging the standard as it exists. So we don't want to augment the standard. We just want to use it as is. So understandable resource names, in other words, are URLs to describe the hierarchy of our data. Control data for HTTP headers for caching and links and that kind of thing. Media types and negotiations. So there's a really big discussion going on, which is actually Leonard Richardson talks about, like the fifth layer and on up of the maturity model, about media types, custom media types, to have your servers do custom negotiation to return predefined domain, I call them domain shapes, but domain objects. Most of, I would wager, Twitter, Netflix, Facebook, none of those APIs commonly return a custom media type. They just return application JSON, and you get to parse it into your model, however you want to do that. So an even more mature above linking would be something that supports custom media types, so that you can define it as a standard as to what that shape is. And then it's also descriptive because of the actual data is text usually that we can read.
Can I interrupt and ask questions now, or should I actually wait for?
No, I meant to say that up front. Just go ahead and interrupt me anytime.
Know that we're talking about representation of data, and you also kind of mentioned about domain representation. One of the challenges when we look at behavior-based API versus a RESTful API, as a model for the whole enterprise, one challenge that we are running into is when you look at an enterprise object model, in the same example that you're saying, like a customer and order. Right? So if you look at a customer, based on the context in which you come into the system, you are interested in a portion of customer information. Versus okay, if you're looking at a system user who's trying to manage customers is coming to the system, their expectation of a customer representation is completely different. It's like a fully blown customer. Whereas a different type of user coming through a different application, which then makes this RESTful call, would expect a different representation of that particular customer, or a subset of that. It's not concerned about the complete representation of the customer system. So I just want to hear your suggestion on, is it in those cases, your recommendation is look at them as different domains and actually model those RESTful services as more domain-based services? Or is there a different answer for it? That it's my question is, if we actually model them based on enterprise objects, then the resource representation is not the same based on how you're trying to actually get to that resource.
Right.
The customer is not the same customer when you actually get it through, let's say, a maintenance application versus an order application.
Right, and you can have different representations based on what the media type is. So, I mean, that's one way to solve the issue or problem. That's the more mature way, I guess, I would say. But that's where all the complexity is, right? Even Roy Fielding talks about the reason we're using a standard, HTTP in this case, is because we want to simplify the transport layer and the communication and all of that. So we want to push the complexity into custom media types. He flat out says that in one of his blog entries. I know none of my RESTful APIs are that mature yet, but that's probably the most standard standoffish answer I can give you. Other than that, I mean, if your URL is a different hierarchy because of how you're getting to it, it's totally appropriate to have a different representation based on what that URL looks like, because it's a different resource.
Yeah, that's one of the answers. Possibly when I look at different solutions for the problem, that seems like a logical solution for it, based on, because a resource is not in this case, customer, I'm not looking at that as a resource that's available across enterprise, based on the context through which you come in, what particular domain that you're trying to actually, using domain-based modeling, you can actually answer the question in a different way. I just want to actually get your opinion on, is it guides? Because if someone is saying okay, is this a true RESTful service because I get a different customer when I actually go through this hierarchy versus a different hierarchy.
Mm-hmm. It was a different URL, so I mean, all bets are off, right? Okay. So REST is stateless. So in other words, there's no state kept on the server side from a context with which a process is going through. So what I mean by that is there is state, of course, kept on the server, right? The application state of a customer has this address, has this name, has these contacts. That's absolutely state, if you will. But there is no state of where we are in the process of a session, where, if you're used to using Tomcat or IIS, you automatically always use, let's stick that in session. Can't do that with the RESTful service because every message has to have enough data, enough information from the URL and the headers and that kind of thing to give you all the context to process that particular request. And we've already touched on the client-server nature of it over and over again. We have a client, we have a server, they're communicating with representations over HTTP in our case. Cacheable. This is getting long-winded, so I'm just going to breeze through these. Because cacheable and layered system are kind of related to me, because you can have a caching layer in your architecture, and just by nature of the client server, you don't know who you're talking to. You might be talking to a cache who talks to a proxy, who talks to a load balancer, who talks to a back-end database. So we just have multiple pieces in the architecture, and that's all he's trying to say there. You just can't make an assumption of who you're talking to from a client. And code on demand, this one's unique in that it is the only optional constraint. And that is that you can read data from a server that changes how the client works. That's how Gmail works, right? Downloads JavaScript, runs it on the client. So that's all that means. And this is the only one we can not adhere to in our RESTful architecture and still remain RESTful. So before REST, in the case of SOAP RPC, we'd have a customer management service that had add new customer, get customer list, get customer info, update customer, delete customer, and same thing, whatever whim we had, we don't have the right get customer info. It's like, get customer info for something, right? So then you have this proliferation of method types, and you go in and you look at the code and you're going, I have no idea what this does. Same thing with the order management system, just a bunch of methods on there that do something, and it's difficult to, if you go back clear to COBOL, right, this would be like G3200_read, and you're like, what the heck does that do? And it referenced back to some document that, was a spec for this or that. So from a RESTful standpoint, we just have endpoints, a customer's endpoint, that if we post to it, that means we're going to create a new customer. If we get that URL, then we're going to get a list of customers. In this context, put usually means update, and that would mean what in that context? Is you're going to update all customers, possible, not likely, and delete would mean that you're going to delete the whole collection of customers, which probably as a business you don't do very often. And then if you have customers with a given customer ID, post is not used in this case because post is used to create, and you probably wouldn't have the ID beforehand, so you wouldn't know what ID to post to. Get will get you a list of customers. Put will update that customer, and delete will remove that identified customer. And the same thing, you got customer ID orders, so all the orders for that customer, and then a specific order for that customer. And this is where I talked about earlier where you have a URL alias, because this and this are kind of the same. This is for a specific customer, this is for all orders. But then how is this different from this? It's not really, right? Orders for an order ID probably gets you the same thing that this does, but in the case that you were talking about, it could be something different. It might not be just an alias. So that's why I boxed these together, because they're They could be aliases, if you will. Same thing for line items. In this context, though, it probably doesn't make business sense to go after line items in isolation of at least an order. So this might not make sense. This particular alias might not make sense. All right, so just a quick recap. What time is it? Anybody? Okay. So we're going to use the HTTP verbs to mean something. Get, put, delete, post. Get means read, put means update, delete means delete. Post means create. It's also the catch-all because of how post works in the HTTP spec. Options for documentation. You don't normally use head very often. Sensible resource names, like we said, in a hierarchy usually. Nouns only. Support JSON out of the box. If it's not too much trouble, doesn't cost too much. XML is nice too. Some people still depend on that. And it's best, we've discovered that it's best to do fine-grained resources, CRUD on a single object type, like a line item, to offer that kind of thing so that you can then come back with a layer over the top and either cache or aggregate at a different layer. So fine-grained resources that support create, read, update, delete. Support caching and pagination. Has anybody here read the best practices document that was produced a while ago? Okay, all right. So we define guidelines for at least eCollege, but it's becoming adopted outside of eCollege across Pearson for how to do pagination and caching and some of the linking practices. So RESTExpress supports those things out of the box. So we'll look at those. All right, so you young folks are always against everything. Is there anything you are for? Yeah, NoSQL. Okay, anybody here used MongoDB before? Awesome. Okay, so if you're familiar with the NoSQL trend, it's for scalability. Primarily for scalability, just so you can have clusters of data instead of a monolithic thing. I won't beleaguer the point here. Today we're going to use MongoDB. RESTExpress has native things built in, a repository pattern built in to support CRUD operations to Mongo. So this slide talks about basically the families of NoSQL databases. MongoDB is a document type store, so you can store a whole bunch of things in a JSON document. It supports, they call it BSON because it's binary JSON, and it supports some fancy things like date types and that kind of thing, but it's essentially JSON. So when you query it, you get a JSON packet back that you can index fields in a JSON document. So it's pretty handy for say a blogging system. All right. What the heck is RESTExpress and why are we talking about it? Because why would we need another toolkit? And that's a valid question, and the reason is RESTExpress is the simplest thing that could possibly work. In my years of creating services and servlets and using Spring, there's a lot of pain involved in development. At least I experienced some. I don't know what you guys where you guys stand on that. I just felt like there was a lot of scaffolding that had to happen in order to just create hello world. So all these other frameworks, Rails in particular, I wrote some Rails apps, thought some of this is pretty cool. We kind of favor the Java platform for its automatic use of your processor. It's easy, it's standard. It's easy to get people that know Java. There's a big open source community. So anyway, we wanted a Java-based framework. And so after using Rails and RESTlet, which are not the same, RESTlet is very painful. Anybody use RESTlet? I'm alone? Okay, that's good. It's a Java-based framework for REST services. You have to create no less than 9 classes to get a hello world out. And it didn't support HTTP 1.1 for a long time. So that was, when I messed with it, it was probably 3 years ago now, so I'm sure they progressed. Jersey's very popular. That influenced RESTExpress because I don't like it. We had a lot of pain with it because, we at eCollege are worried about a lot of scale, easy scale, and so a container really doesn't work for us very well. So Tomcat and any of the JEE containers we kind of steer away from because we want to use the whole machine for processing, not for mechanics and scaffolding. So between Sinatra, Node.js, and Rails, those were kind of the big pushes for the kinds of things we liked. And Glassfish, Jersey, Spring, and RESTlet were kind of things that we withdrew from and said we kind of don't like this. So RESTExpress is written on top of Netty, which is a Java-based non-blocking I/O framework. So it's actually a thin veneer on top of Netty. It uses the HTTP codecs that Netty provides, and basically is just a URL routing service on top of that. But then we plugged in the ISO 8601 time point handling for JSON and XML, and marshalling for JSON and XML. So I'm basically, like I said, Netty uses JSON for its JSON processing. We might move to Jackson shortly. OR mapping, it uses Morphia, which is a MongoDB OR mapping tool, open source. Let's see, domain validation, it does support that. Basically, RESTExpress is a suite of what we call micro frameworks. It's kind of a buzzword now, but it's just a bunch of little pieces we plug together. Syntax is a domain validation library that does, it supports annotations-based validation, a lot like Rails. And then we have ISO 8601 date support so that you can read the dates in your JSON packets. Most people use a long, ticks since 1971, and we found that wasn't readable, so we standardized on ISO 8601. It's translatable across all platforms that way. And then we have domain eventing and, yeah, I'm sorry.
So you weren't able to get the date support you needed from Nissan or Jackson?
We haven't messed with Jackson much. So no. JSON doesn't have any real date processing. I mean, Java doesn't support ISO 8601 dates. So unless you use, I forget what the other time library was, that, and that was really heavy. We just wanted one thing,
What is the 8601?
The ISO 8601 time point gives you a date portion and a time portion, and it's unique and that it separates the time zone with colons. So if you use the simple date format, it doesn't put it in ISO 8601 format. So there was some little tweaks we had to do on top of the simple date formatter in order to get there. That's basically all this is a layer on top of simple date format. And that's the real reason we didn't go with another library. It's like pull in all this stuff for one little tweak. We're going to string and from string. Figure out how to do it. It's not really that hard. So, all right. So it's super simple. You just need an application delegate, a window, a view controller, a layout manager, an output stream, a buffered output stream, and that's your hello world, right? Yeah. Anybody experience that? I know I have. Okay, so here's a minimal RESTExpress server, and what this does is an echo. If you've used Node.js, you might. This came out of a Node.js example that does echo, and so we have just Java stuff. We have a class here. We have a main that takes some arguments, which are ignored, by the way. So we create a new RESTExpress server, and here we give it a URL or URI that's /echo, and then we pass that a controller that's going to handle the request. So here, a controller, one of the things we didn't want to do is have a hierarchy of classes that do a bunch of stuff. So a controller is just a POJO, new object, and we implemented the read method, which, since we embraced convention over configuration, a get equates to a read. So a get operation on this URL will call this method, and we get passed a request and a response. So we get the value from the echo parameter in this case. Everything in RESTExpress, whether it's a query string or a header, comes in as a header, and you can decide whether you want to get it raw or URL decoded. So you're probably asking the question, well, what if I have both a header and a query string parameter? The query string parameter overrides it. So the last thing, so you can set it either via a header, or we can pass in a query string value of echo, echo equals, and it will get set there. We're going to set our response content type, which is not necessary. We only had to do this for echo because RESTExpress supports JSON and XML out of the box, and we're kind of doing some magic here to return XML, so that's the only reason we had to set that. So if we don't have a value for the echo parameter, we write some XML back out and return this string. Otherwise, if there is a value, we do some string substitution and return that. So here, we're at the end of the URL definition, but with method chaining, we're going to say, okay, well, I only want to support the HTTP method get, since we only have one method here. Otherwise, we'd want to provide a read, create, update, and delete method to go along with all four HTTP methods. We're not going to do any serialization, so that essentially turns off RESTExpress's XML and JSON serialization. And we're going to bind it to port 8000 and wait for somebody to hit Control-C. If we run that, it'll sit there and listen on port 8000. And when we send it a request for this URL, we'll either get this string or this string with our value substituted. Any questions so far on the structure of the simplest RESTExpress server? All right. So boss, we've just finished the web service. Great. Do we now have a SOA? No, it's just a web service. He's not real happy. Okay, we'll call him SOA. How to get a SOA. All right, a little dated, but we just made it into the SOA era. All right, so what are we going to do today? Our project, that's going to work out good. Our project is going to be a blogging service suite. I realize that everybody and their brother does here's how to create a blog with Ruby. The reason I kind of chose that is because everybody does it. Here's how to do a blog with Python. So, that being the scope of the project is probably easily understood. We don't have to spend a lot of time on requirements. And the new technology stack is going to be hard enough for us to grok in the meantime. So we're going to create 3 domain objects, a blog, an entry, and a comment. We're going to do create, read, update, delete in Mongo. We'll do some domain validation based on what's required. Maybe we can get fancier if you want to put some fancy stuff in our domain here. We'll show how RESTExpress handles errors and how we can easily map those errors, whether runtime or watched exceptions, back to HTTP status codes. We'll use the built-in caching support and the location header stuff. Pagination, sorting, and filtering is built in, so we'll show how that stuff works. And maybe we can get fancy with some relational links and asynchronous cascade delete. What we got? All right. So with that, I'll let you have your break.